In this video, I will show you how to describe transformations to functions that involve stretching the function, compressing the function, or sometimes flipping the function. Here we have got two examples. They both have a 2. The first one says +2. So like what you have seen from the previous video, you can write the order pair 0, 2. Because the y coordinate is a +2, this went up 2 units and the x did not change. Now for this one, what is new about this is what happens when we multiply. This 2 is being multiplied to the function. And when you see multiply, if the number is bigger than 1, it's a stretch. If the number is smaller than 1, it's a compress. And so I want to help you visualize what that looked like by looking at some graphs. So here are 5 graphs about absolute value. And so you can really do this with any function, but I just pick absolute value because absolute value is the easiest to see the stretching and compressing. So the original one is on the left, just f of x. The second one, you see how this is being multiplied by 5, which is a number that's bigger than 1. And so you see how this is stretched vertically. So imagine you taking the function and you pulling it up and down, stretching it. So this is a stretch. Now the next one, it looks like someone stepped on this function and squished it, compressed it. And we see that by multiplying by 1/3. 1/3 is like 0.333 going on forever. And so it's a number that is smaller than 1. So that's a compress when you see a number that is smaller than 1. Now the third example has a -5. And so the negative part tells you that it is going to be flipped. So you can see that this graph, it got flipped upside down over the x-axis. So this has two things. It got flipped. It got reflected. And also that it got stretched. And we see that number that's being multiplied as a 5, which is bigger than 1. So that's a stretch. And this last example here, that negative tells you it's going to be flipped, or actually we should say it's reflected over the x. And because it's 1/3, which is smaller than 1, it is a compression. So let's look at some examples and we will describe the transformations. Here is one example that a lot of students get confused with. They see a -3 multiplied to f of x. So some students will say that, oh, this is going to be a compress because -3 is smaller than 1. But that's not true. This negative part tells you it is reflected over the x-axis. But then when you look at this 3 part is bigger than 1. So this is still a stretch. Another common example is students think that fractions always mean that they are smaller than 1. That is not always true, because if you take the 7 and you divide that by 2, you get 3.5, which is bigger than 1. So here's a really quick way to tell if a fraction is bigger than 1 or not. If the top number is bigger than the bottom number, then it's larger than 1. Then it will be a stretch. If it's smaller than the bottom number, then it will be smaller than 1. It will be a compress. So this one is a stretch. And we don't have a reflect because this is positive. In this example, all we have is this negative sign, which tells you it's going to be a reflection over the x-axis. But because we don't have a number that's being multiplied in front of this, this does not stretch or compress. So all we have is a reflection. In this example, this 1/2 that is being multiplied is smaller than 1. So we know this is going to be a compression because it's smaller than 1. But no reflect because the 1/2 is positive. If it's negative, you'll say reflect. And now looking at these numbers, so inside change from the first video. So -5 becomes +5. Outside stays the same. So x coordinate, y coordinate, and so positive x, we say it went to the right 5 spaces, and positive y, it went up 8 spaces. So these are the 3 transformations we have. It got vertically compressed, got moved to the right 5 units, and got moved up 8 units. For this example, this negative sign tells you it is going to be a reflection over the x-axis. This 5, because this 5 is bigger than 1, it's going to be a vertical stretch. And now let's look at the numbers and write a coordinate. So this -8, because it's inside, changes to +8 changes to -8. And because we don't have a number outside, a plus or minus number outside, that is going to be a 0. So one common mistake I see students do is that sometimes they will think that the -5 goes on the y. But any outside number, you have to ask yourself, is it being multiplied? Because if it's in front, like this case, it's being multiplied, then it has to do with stretching and compressing, not moving it up and down. So -8 on the x means that it went to the left 8. So the transformations reflected over the x, got vertically stretched, and moved to the left 8 units. For this example, this negative sign tells you that it will be a reflection over the y-axis. This 3/2, because 3 divided by 2 is bigger than 1, this will be a stretch. And then let's look at the point. Inside we don't have x plus or minus anything, so the x coordinate is going to be 0. And outside we have this -2. So -2 over here, x and y. So a negative in the y direction tells me that this is going down 2 spaces. And so here's our answer. Got reflected over the x-axis, got stretched by 3/2, and got moved down 2 spaces. So in this example, you will do the opposite. You will write a function given these transformations. So transformation number 1, it reflected over the axis, the x-axis. So what that tells you is that we have a negative sign. Transformation number 2 tells you that it will be compressed by 3/4. So we know that in front of this we will multiply by 3/4 f of something, but let's see what that something is going to be. And then the last transformation tells you that it got moved to the right 5 units, so we know that the x coordinate is going to be +5. Okay, let's put the 5 over here. So the x coordinate is going to be +5, and the y coordinate is going to be +9 because it went up 9. So x and y. So now let's be careful. Inside, this 5 is going to change to -5, so x -5, and outside stays the same. So this is the answer.